All right, you guys. Matthias, Jessica, thank you so much for joining me.
Hello.
Hi.
Nice to be here.
So today we're talking about a pretty fun topic actually, because it's one that we often get asked about, and that is, as Ignition Premier Integrators with quite some experience in building and implementing SCADA solutions, how do you guys handle a project, and especially when it comes to customized SCADA solutions for our clients and at a pretty big scale like we've done for some companies? How do you guys do it, and how do you do it well? I think that pretty much encompasses what we're going to talk about today. But I'm going to shut up and I'm going to give you the floor because you guys have the good stuff. So let's see what we're going to talk about.
All right. Thank you very much, Julia. Yeah, so basically, we're here to talk about how to build a huge SCADA solution without making a mess. So basically, what we do is that before we start, we need to consider a few things in terms of what is already existing. Does the client know what they want? What are the deadlines? What do we know about this subject or the domain knowledge of this field? And are there any things we need to learn upfront, or is it something we can learn throughout the process, basically? So that's the things we need to consider beforehand. And often the clients already have something that they as a starting point, basically. So maybe a existing SCADA system, or maybe it's not even a SCADA system. Maybe it's just on whiteboards or whatever. They want a solution that can do a specific thing, but they have an idea of what they actually want to achieve. So that's something we need to figure out first, and also figure out, like, is there anything in that is a problem for them? So now, for instance, if they have a SCADA system, it might be that there are some functionality they're actually missing that they need to do as in the new system, or that maybe that's the whole purpose of actually changing that new system. So there are a lot of things that we need to consider from the beginning on. And here we have listed some of the parts. I'm not going to read them out loud, but things here is the typical things we're going into. Then obviously we have these deadlines, and we want to break everything in to these sprints as much as possible. Usually we go with sprints of 1 week, but it could also be bigger sprints if needed. But it's a nice frame of actually getting something done with 1 week. So if you have a big system or big elephant, so to speak, cut it down into smaller pieces and then just do it little by little. That's a much better way to work for us. Then we come down to what we already know about this, and for this, usually we have a domain knowledge about some of the projects we have. So we have been doing projects previously in this inside this domain, so we know things about how it should be done, how others have done it, and that gives us an edge on how to do this, and also that we know these are usually some of the pain points that other clients are facing when trying to do this. Then we know that already, and we can actually dive into that, and we have ideas and solutions already for topics like that, and challenges like that. But obviously we will always come into situations where the client has some new things they want to do, and some new requests or new ideas on what they are expecting to see, and there we can always learn some new stuff. I don't think we have ever done a project without learning some new stuff, so I think that's something we always bring with us. So what we are focusing on a project is the architecture, the visualization, the integration, and that's the main things we are focusing on. And we do this by simply simplify everything, and we focus on reusability as much as possible and the coherence of it. So if we talk about the architecture, then basically we can divide it into three parts. So when we're talking about vision, then we have the UDTs, the windows, and the templates. The UDTs is our whole structure within the tags. Here we tend to use the IC95 standard for the actual tags, and then for our UDTs, we group them into these natural logical tag groups of how they should be done. Then for the windows and the templates, it's a bit more case by case how we want to structure it. It depends on the project as a whole and what features they're needing. But we usually split it up. So we have, for the Windows part, we have basically one folder for a plant, and then all the sub windows for that specific plant. And also, if we have some bigger plants, then we might have some subfolders for sub areas of that plant. And for templates, we order it in or structure it so that we can reuse as much as possible. So we make it into some logical groups based on if we have some faceplates, we have some components, we have some sections for the faceplates, and so on. So we try to make it as reusable as possible always. That's some of the things we always keep in mind when we do projects. Always to whenever we build something, we need to make it in a way that we can actually reuse it over and over again, so we don't have to make the same faceplate or the same window multiple times, but we can actually just reuse it and parameterize it, and then by that use it again.
Yeah, that makes sense.
So this is the part where I mostly come in, and it's based on what Matthias already said. We need to figure out how to divide and how to reuse what we can, because we don't want a messy project where you're confused about, is this section for this part, is this component going to be used here as well? So we start by defining our windows, our sections, and our templates. So a window could be composed of various sections, and those sections have templates as well. So the idea is that if, for example, this is a broad example, we have a PLC component, a motor, for example. We have this type of motor, and this type of motor, and this type of motor. 3 types of motors, and they display the same kind of information. Then we don't want to create 3 separate faceplates with various separate sections and templates. We want to reuse them as much as possible. So perhaps the only thing that changes is a word or the unit of a value. We can achieve the reusability by parameterizing our templates and sections and using indirect bindings in our windows. So this is where we try to also integrate various parts of the solution so that they can coexist in the same world. So we use modules and functions for this. We create a part that shows the faceplates and the values that the PLC components have, but they also, the client could also need, like, I need a reporting module. So instead of seeing everything like a separate thing, we try to implement it in a way that is coherent and that it flows. So the solution actually is composed of various modules. So we can give the best, most complete solution to our client. So in the next page, the next slide, we can see our part of our execution with the simplification being used as not being redundant. Like if we have a window and it's displaying the values of a motor. And we have the name of the motor on top. We don't need to replicate that on the bottom and on the other side. Like, let's just focus on our on the most important information, and let's not repeat it. That way we can organize the window better, and the person using it doesn't get distracted by trying to search for a certain information and just coming up with the name of the motor time and time again. So in this case in particular, we have a search plant, but we already have a search bar on the top. So we don't need a second one. We already have one. And we have the plant name, but okay, we already have it on top of the symbol. So if it's not that important of a thing to pop out in the window, we can remove it, because I'm sure that they do need the plant name, but the values are more important. Also, for example, in the alarm table, we have an alarm name, but you already have a tag name, an alarm name, and description. So why would you need another column with only the alarm name? You can simplify that. So in the next slide, we can see more of what simplification means for us, like being minimalistic, meaning that we don't have many flashy things popping up on the window, so that the attention of the user can go to the important stuff. For example, values and active buttons and active status. We don't need a fancy generator symbol to just be flashy. We need something that doesn't take away from the important information. So obviously we need to establish a design hierarchy and design styles that are going to be consistent from one window to the next, from one section to the next, and from one template to the next, all over the solution for the client. So we establish that, and if they agree, then we proceed to design each component and template and faceplate and etc. On the next slide, we have our reusability, which is the components and sections. In this case, we use parameters. Like, we don't want to create a status section for a motor that is going to be the same status section for another motor. We can reuse that one and have one less thing in our architecture, so we don't get confused. So in this case, we can see that the first one, the generator, is the same component, like the same image, so we can reuse that. And the second section is actually showing the same kind of values and the same amount of values, so we can reuse that in different faceplates. On the next one, the next slide, this is also what I was talking about, the parameters and indirect bindings. On how, this allows us to see how we can reuse those sections and components without having to make a copy and changing just a few things. It's important to establish from the beginning, and this, you can establish it and you can have a plan, but you need to be able to revisit that plan once you start implementing, because there's going to be some changes as you go. But the main idea is to have everything indirectly bound to the tag tree, so we can decide if this is going to look into this folder or into this folder. But the termination, that's why it's so important to have an organized architecture for a tag tree. The folders, if they remain the same name, you can actually change the first part to see in different tags. So you can access a motor and see the alarm because it's in an alarm folder. And you can access a valve, which has also an alarm folder. So you just change the bit before the name of the folder. So that's indirect binding. And we do that with parameters. Like we tell a component, look at this indirect binding, and with this final string that is looking inside the folders, and it automatically assumes which one you are going to access by just putting the first part. So if we are able to do that, it's great because then we don't have to do 3 times the work. But it's important to establish where to stop with how detailed we want to be and how open we want to be. Because if you go deep and deep and deeper, you can run into being so specific that you need to create another section. But if you are very broad, then you won't be able to show as much information as you need to show. So it's important to just go up to a certain point and say, I think this needs to be another section, or this section needs to be duplicated specifically for this component, because that happens. That's why I say it's important to be able to go back and revisit some of the decisions you made at the start, because they are not going to hold up as much as other decisions once you start to implement and grow the project. So we've run into that a lot, and it's important. That's the learning part, because when we revisit, we can see that we made a mistake here because we were going to intentionally do this, but then we grew, and now it's not as efficient. So let's go around it and find another way to do it.
Yeah, and I also have a comment to that one actually, because sometimes when you have these where you want to standardize everything and have one template or one faceplate and be able to reuse it over and over again, as Jessica was saying, at some point it might not be efficient anymore to have just one, because then you also need to take into account that that specific, so generator 1 was like this and generator 2 was similar, but with one change in it has an extra value or something like that. So then you need to make the decision: are you going to reuse the generator 1 faceplate or component or whatever it is, and then you reuse that for generator 2, and then either make it more advanced so you can actually figure out the value there, or would you need to instead make two different versions and then say, well, if it has that value, then we need to use option 2, otherwise it's just option 1. So it's always a balance, as Jessica was saying.
Yes.
Yeah, and I think that's a very good point to make, that even though at the beginning we have a plan and we're going according to it, we don't have like tunnel vision only for that plan, but rather we adapt to continuous changes as the project grows. So I think that's a very, very cool thing.
Yeah, we need to be critical of ourselves, because it happens. It has happened to me that I fall in love with a solution and I say, like, this is the way to go. And when I see that it doesn't apply to everything, it's hard to say, like, okay, this is a solution that works for certain things, but they need to be there needs to be some tweaking done to work for this, and not be able to say, okay, this needs to change, and not find a complicated way around it so that I don't change the main idea and it just ends up making a mess. So if we see here, this is what we were talking about, by being coherent, like knowing where to stop with the parameters and the indirect bindings, because it can get messy pretty quick. In this case, for example, the same type of information, the parameters could be the name, description, values. For values, we're displaying. For value units, we're displaying for, and the symbol status. In this case, in the first column, we can see that they are basically the same. So we can reuse that section. But in the second one, since we have different type of information, we would need many parameters and many bindings in order for it to work with the same section. So that case, we should probably make two sections, like two different templates that show the same status information, but cater to each of the components. Like, for example, in the gauge, we have like 4 values and a symbol, but in the generator, we have 3 and some other stuff, so it wouldn't work. In the next slide, this is very important because this is like how we established that this section could work with this and this component, and this template could work with this and this section. But how do we construct the window or the faceplate? We create building blocks. We create instead of creating everything inside the window, we make these sections as templates so we can reuse them and bind them as we see fit, and then we can create like not a house but a building in each of the faceplates. Like, for example, in one type of motor faceplate, you could need a status section, but in another motor, you wouldn't need it. So you create 2 faceplates, and in one of them, you just don't use the status section, and that's it. Instead of like copying everything, if we were creating it inside the window from the start, instead of copying everything, you just reuse and omit those sections or templates that you don't need. And we basically just use the bindings and parameters to make it work. In the next slide, we can see a little bit of how we use the direct and indirect bindings. For example, when you are using a binding to display a name or a description, it could be direct because they can input the information, and it will always show like motor 1, or this motor is for a pump, and that wouldn't need to be accessed through the tag tree. But for values, it's different because those are going to be coming from a PLC, and they're probably going to be stored in a database. So that there we can't be like direct if we want to be able to reuse. So in that case, we use indirect bindings, where we establish the first part of the tag path, and the ending, since we already have a structured architecture of the tag tree, should always remain the same, unless it's not the same. But usually it is. And you can find the alarms in the alarm folder, and you can find the status in the status folder. So we just change everything that is previous to that folder, which is the name of the tag, like the PLC component that is going to be supplying us with that information. And we can see on the few slides that are left some of the examples of how we managed to do this architecture of the UDTs, faceplates, and components. The first one is the UDTs, how we organized for example, the analog component. It has an alarm folder, a command folder, a notes, status, and this is replicated in the other components as well, like the digital component. It should have more or less the same structure so that we can reuse these sections. The windows, we organize them by faceplates. Then we have like specific folders for each type of faceplate, for each component. And in the templates, we usually have like a common folder that is going to be reused throughout different types of components, windows, etc. And then we have the sections and the components as such, like the shape of the motor. And well, these sections are showing the alarm section for this type of component because it differs from this other type of component. So we have different alarm sections, but we always like detail what they are used for, because we don't want to just drop one and say, oh, this wasn't it, it's the other one. No, we just place it on the name so we can easily access that section that we're needing. The integration part in the next slide, we can see that they have we made like a plant navigation, that is the one on the back, where you could search a plant or whatever it is you need to access. And then we have the faceplate, like this. Well, this is not the faceplate. This is like the perspective version of that pump station in this case, which shows different components and different information that needs to be easily accessed upon seeing. Obviously, you can then click on the motors and the pumps and etc. and see more detailed information. But the main values, the name, the status, you can actually see it all in one place. In the next slide, we have more of that integration, which is the logbook, where you input something that happened and you want to make a report. Well, not a report, but log the information in. We can make that possible. We can also have a report that could be sent every morning, every afternoon, regarding the alarms, the user information that was input. And let's see, the last two slides are about the simplification of the window. And the first example, yeah, it's pretty confusing because you have different colors, a lot of text, and you can't readily see the information that is important. In the second one, we take away everything that is not needed and just make it very light colored. The things that have color is because you need to pay attention. And we make it as simple as possible, as white as possible, so you don't get confused, and also organize it a little bit more. And in the second slide, this is an example of the faceplates with how they were simplified and also updated in the design, because the previous design was very 1980s. That's my personal opinion, but yeah, it also it goes easy on the eye to have a lighter background than a darker one, because you tend to get pretty tired. So if you have a lighter background, then the eyes just roll around with the darker information instead of the other way around. So this is basically it.
I think the main message is that we focus highly on the architecture behind the scenes, because if we have that very streamlined as much as possible, then it makes the whole front end a lot easier to work with, and we have some options there to actually make it very reusable and not having to make everything twice, 3 times, 4 times, or whatever. But we have the option to actually minimize the amount of work we need to do in order to accomplish the same thing in a smart way. So I think that's some of the things there that we focus highly on. So the architecture and the reusability there, and also the simplification and coherency, as Jessica's been talking about as well. So I think that that's the main topics that we really try to focus on a project on bigger projects, in order to, yeah, as the title says, not make a mess. So yeah.
I think the conclusion here is that you've managed not only to make the design so much simpler and more intuitive, but you actually made the process of building this so much more efficient, which is a win-win for both us and our clients from many points of view. So this is absolutely amazing. And like you said, Jessica, it's always a learning opportunity for future projects as well. And I think one of the cool ways in which a project grows is actually um, the more we build and the more we use Ignition and the more we show our clients what's possible, they get like, oh my God, can we actually do this? And and that's always such a fun thing.
Yeah,
Yeah,
they
Yeah, totally.
actually end up having like, oh, I didn't know I needed that. Now I
yeah,
need it. So we actually not only solve their current needs, we actually provide a gateway to satisfy uh, upcoming needs that they didn't know they had.
yeah,
Uh, when we start out with projects, the client has some specific requirements for the project and what they want to achieve and all that. But then as we go more and more into the project and we start to have some things and show them, hey, we can do this, and the solution you asked for, we have done that like this and this, and then it slowly, once the basically the ball has started to roll, then all sorts of ideas will come up all the time. And actually sometimes we have to say, well, you asked for this, so let's focus on that. And they're like, okay, yeah, that's true, but because suddenly they want everything. If you can do that, this, can you also do that, and so on. So I think that's where Ignition as a platform comes in, because you have so many options on Ignition, to build more or less anything. So we tend to say that the good thing about Ignition is that you can build anything. The bad thing about Ignition is that you can build anything. So it's
Exactly.
it's there's so many options, and and sometimes I think for clients it can be hard to actually um, just get what they need, because there's so many other things that we can also do this and that. So I think it's that's also part of our role, to actually be able to deliver what we have agreed on in the beginning, but also be able to adjust the course a little bit over the time, because new ideas will come, and it makes sense to actually maybe change the prioritization throughout the project, because something else has actually turned out to be more important now that they know they can do it, than something else that they thought was important.
Yeah.
So yeah.
yeah,
Yeah, it works both ways, because sometimes they think that they need something and they figure out that they actually didn't, because you can solve it in another way that integrates with something that they did need. So it goes both ways.
Mm.
yeah,
Yeah, and sometimes there are things in Ignition that you do in one way, and in other systems it's done in a different way. And if they're coming from a different system, and they say, well, we need to do it like this and this and this, and then once we start to talk about and start to spec to find the specs for that task, and what it is they're trying to do, and all that, then it turns out that, well, that's actually not a problem in Ignition. We don't even have to. Maybe it's we have cases where it's something they need, and that's because the old tool is working in a different way. And then once you want that in Ignition, then it's not something you need to build from the ground up. It's something that's just by standard is supplied in Ignition. And other times it's different stuff that you need to do in a different way, and that's also why we structure everything, so we can easily change parts of these things. And if something, or it could be a faceplate, suddenly has a new feature, and they want
Mhm.
to add that as well, then we only have to add it to that specific section, and then it's on all the faceplates. So that's also something there.
yeah. So stick to the plan, but also be adaptable and flexible.
Something like that. Yeah.
Yeah. All right, you guys, you've done amazing work here, and thank you so much for this.
No, thank you for the opportunity to share
Yeah.
our growth.
All right. Well,
Exactly. Thank you very much, Julia.
thank you, and see you soon.
Okay, bye-bye.
Bye.